pt-1.com.
Okay, today we are going to discuss some important questions from the isomerism and IUPAC nomenclature. So let's start with the 2019 question. This is the IUPAC name you have to give. So here we have two things for the reference preference. Here one double bond is there, one triple bond is there. So as per IUPAC nomenclature, if they are equidistant, you have to give the preference for double bond, not triple bond. So we have selected a chain which contains the double bond and triple bond. We should select a chain which contains the double bond as well as triple bond, but numbering should be done in such a way that the double bond gets the minimum numbering. Okay, and here it should be known that equidistance only. If they are not equidistant, then we will follow the lowest sum rule. If not at equidistance, then lowest sum rule. For example, instead of double bond here, if it is there here, then we will number from the both direction. Wherever you get the lowest sum from that place, we will numbering. Okay, we will do the numbering. So now I have selected this chain, I think clear. So why I have selected this chain? Because see here, double bond and triple bond both are done. And why I have numbered from here? Because lowest number should be given to the double bond. Now arranging the terms. First we should write the prefix. In that also we should write alphabetical order. Okay. So here this is methyl. This substitute also methyl, and here this substitute is propyl. So out of this, the lowest alphabetical orderly we should write about the methyl MNOP. So first we should write about the methyl. So methyl we have at the two different places. Okay, so that is at 3 and 5. At the two different places, 3,5 dimethyl, 3,5 dimethyl, then propyl. Propyl is available at fourth carbon, 4 propyl, 4 propyl. Then total 7 carbons are there, hept, and one ene, and 6 ine. So this is how we have to write the naming. First prefix and in that also, if two types of substituents are there, follow the alphabetical order M and P. M comes first, that's why methyl, then P, then word root, then primary suffix. Okay, as there is no functional group, secondary suffix is not required. This is how you have to write the naming. Okay, next question is the question which contains the polyfunctional group. So let me identify the functional groups available. Here one is alcohol. Okay. Another functional group is amine. And third functional group is nitro. So nitro, and halo and alkoxy. These three are the functional group, but always treated as a substitute only. The functional group which are treated as a substitute only what? Nitro, halogen, and alkoxy. Normally, this is what ether also, alkoxy means. Okay. So they always written as a prefix as a nitro, halo, and alkoxy. So there is no doubt about this. And we have another functional group, aldehyde. Okay, in the priority order, aldehyde comes the first, and the amine, alcohol, nitro follows the next. Okay, so therefore we should give the preference to aldehyde, not to the alcohol, not to the amine, not to the nitro compound. So the numbering and suffix must be written with respect to the aldehyde only. So this is the first preferred. Once whichever is first preferred, that is written as a suffix. Okay. Remaining all, whatever the second preference, third preference, fourth preference are there, they are all written in the prefix. This is also written in the prefix. This is also written in the prefix. Okay. Whichever is not in the first, that is written in the prefix. Only first is written as a suffix. And numbering is also done according to the priority only. So this carbon must be written first. Okay, one. Then you should follow the lowest sum rule. So as per the lowest sum rule, if I follow this direction and clockwise direction, 1, 2, 3, 4, 5, 6. So why I have selected this only, I think clear. First preferred, first number, then lowest sum rule clockwise. Okay. Now arranging them in the increasing order, sorry, alphabetical order. Here A and A. If first alphabet is same, then you will compare with the second alphabet. Okay. So here for this prefix is what? Amino. For this prefix is amino, and here alcohol prefix is hydroxy. Alcohol prefix is hydroxy. Nitro prefix is nitro only. So A, H, and N, which will come first? A will come first. That's why we will write amino first. Okay. So first we will write 5 amino. First why 5 amino, I think clear. Once A is over, out of H and N, what will come first? Hydroxy. Okay. Hydroxymethyl. See here, methyl also there. So 4 hydroxymethyl. Hydroxy is on methyl group. Okay. Hydroxymethyl. So after H, then N is left over. What is that number? It is second. On second, it is nitro. So 2 nitro. Then total, it is a benzene, and benzene, this we are not counted in the word root, aldehyde. So aldehyde we will write. Okay. Benzaldehyde. Benzaldehyde. Once again, I am repeating the same procedure. First, we should check with which is the highest in the priority order. So, on the priority order, aldehyde is the first. That's why numbering is done according to that. Aldehyde is written in the suffix. Written in the suffix. Remaining all are written in the prefix as per the alphabetical order. So, for lowest sum rule, for following, I have went through the anti-clock, sorry, clockwise, so that 2 plus 4 plus 6, 1 plus 2 plus 4 plus 6 will give you the minimum possible number. So first prefixes in the alphabetical order, then word root, then suffix. So this is how you have to name the functional compounds with more than one functional group. Okay, next question with the combined with the isomerism also. See here, E stands for the antagon. Antagon means Z is cis, E means trans. Okay, so here let us check with the naming. So again here it is a equidistance 1, 2. In the second carbon we have the triple bond 1, 2. We have the double bond. So we have to give the high priority to the double bond along with the substitute also it is available. Okay. So here the numbering should be done from double bond, nearby double bond. So I have continuing with the 1, 2, 3, 4, 5, and 6. Okay. So anyhow, everywhere it is E is there, so that won't be a matter of concern. Now we should start the naming for this bromo is there. Okay. So on what carbon it is there? According to this second, so 2E. Okay. First one is what? So here it is one methyl group also there. So 2E and two similar groups are on the opposite side. That's why it is trans. Okay. So 2E and then it is 2 bromo. Okay. 2 bromo. 2 bromo. Then how many carbons are there total? six carbon atom, two bromo, hex, and four double bond. Four double bond and four triple bond and two double bond, En and N. So once again, 2E that is on the second carbon, this is attached to 2 bromo, second got the bromine and hex, total 6 carbons are there, 4 got the triple bond, 2 got the double bond. Okay. So this is how we can write the naming of compounds with double bond, functional group and triple bond as well. Okay. So next, coming to the next question, arrange the following conformational isomers of N-butane in the order of their increasing potential energy. So you should know that energy more and stability will be less. All related topics also I am revising. Energy more, stability less. Okay. More energy, less stability, and energy will be more when repulsions are more. Repulsive energies only will be considered as energy. So see here, methyl and methyl are separated opposite 180 degree. More separation, less repulsion. See here, less separation. Here also less separation. Okay. And here over very, very less separation. Okay. So here we can see maximum stability will be there in the first. Maximum stability will be there in the first. So minimum repulsion. So minimum potential energy. So one will be the lowest. Okay. So here you can check one and one. So you don't worry about first option and third option. Okay. So if you can compare about the 4 and 3, that is sufficient. In the 4, methyl and hydrogen are very nearby. Okay. Because see here in the second, fourth and what? Third. So methyl are separated, methyl hydrogen are separated. Okay. And the gap between them is here at least 60 degree. Here it is less than the 60 degree. Therefore, after that maximum repulsions are found where uh, 1 less than 3. Okay. Then coming to the 4. Then coming to the 2. 1 less than 3 less than 4 less than 2. Okay. 1 well least because 180 degree. Second 3 less than because they are separated by 60 degree. Here I am writing the degree also. Fourth, in the fourth they are less than the 60 degree. Okay. So they are less than the 60 degree, and here 2 is just overlapping with each other almost. Two bulky groups are overlapping with each other. So option for correct option is 1 less than 3 less than 4 less than 2. Okay, so fourth option is correct. Okay, next question is about the addition reaction and isomer produced. Stereoisomers that are formed by electrophilic addition of bromine. So electrophilic addition will be taking place in presence of the CCl4. Okay. So Br2 oblique CCl4. Actually in this, like this cleavage, Br plus and Br minus. So Br plus will start the reaction. That's why it is called electrophilic addition to the trans butene. See, this is what butene. Four carbons are there. Second carbon got the double bond, and the methyl groups are on the opposite side. That is trans butene. Now, when you are adding trans and here bromine in carbon tetrachloride is a anti-addition. That is a anti-addition. As a memory technique, you should remember the TAM. Okay. Trans anti-addition will give you the meso compound. Now, anyhow, I will explain here complete meaning also. See, if I keep a mirror like this, bromine reflected bromine, hydrogen reflected hydrogen, methyl reflected methyl. So this is a plane of symmetry is available. then such compounds which are optically inactive due to the presence of plane of symmetry, even though it contains the two chiral center, it is optically inactive due to plane of symmetry. Such compounds are called as a meso compounds. So this is what the product. Okay, so both are meso compounds. Okay, two identical mesomers is the answer. Okay, what you will remember, trans, anti, meso, tam. And when it will take trans addition, bromine, when you are adding to the double bond, it will undergo trans addition. Next question, compound with molecular formula C3H6 oxygen. So 3 to the 6, that means it is following the molecular formula CnH2n oxygen. So whenever such type of molecular formula is there, either they will be aldehyde or they will be ketone. Aldehyde and ketone are considered as functional isomers. They are considered as what? Functional group isomerism. So this question answer is functional group isomerism. Okay, up to now we have studied the where name is given, sorry, structure is given, name you have to write, but here name given, structure you have to write. Okay, first you will write what? Cyclohexane. This is cyclohexane. Carbaldehyde. This is carbaldehyde. Okay. So then this becomes alpha, this becomes beta, this becomes gamma. And on the gamma, we have to write methyl. So aldehyde structure is like this. Okay. So then the answer will be like this, where you are able to see alpha methyl cyclohexane carbaldehyde. See, this is carbaldehyde, alpha, beta, gamma. Okay. So that's why first option is correct. Okay, next question is about the classification of the compound. So here, this compound contains the oxygen in between. Okay, and there is no pi bond, so there is no chance of the aromatic compound. Okay, so when one of the corner occupied by any other other than the carbon, then it is called as a heterocyclic. Okay. And when two rings are joined by, this is one triangle, this is another triangle. Two triangles are joined by two common carbon. Then such compounds are called as a bicyclo compound. But when two triangles are joined by one common carbon, then such compounds are called as a spiro compound. So aromatic already we have studied thoroughly in the GOC. So here one lone pair, two pi bonds. So total 6 electrons. So that means 4n+2 rule is followed. Therefore it is aromatic. So A answer is 3 and B answer is what? Bicyclo. Okay. B answer 4. A answer 3 non-planar. B answer 4. And C answer 1. And D answer is what? Aromatic 2. Okay. Now very good important doubt is here two lone pair are there on the same element. We will consider only one. Let there can be three lone pair also at a time. One lone pair only participates in resonance. So even though these two lone pair are there, any one of them only considered. That's why 2 plus 4 electrons in the pi bond. Okay. So this is the final answer for the given classification question. Okay, then decreasing order of priority of functional group. As we have studied polyfunctional group priority order, the topmost functional group which is given highest priority is SO3H. Okay, then COH is given, but in this COH is not given. So SCOCl, then amide. This is acid chloride, then amide, then cyanide. Okay. So for this answer is second option. Now let us see the next question. Here both are appearing like ketone, but actually this is together it is aldehyde. Among the aldehyde and ketone, aldehyde is more prior. Therefore, numbering is done according to this 1, 2, 3, 4, 5, 6. On the sixth carbon on 7. So 7 carbons are there, hept. Okay, and this is written as a prefix, less prior, more priority only written in the suffix, less prior, and all are written in the prefix only. So nitro, and this is written as a oxo. Okay, so and methyl also. First, what we should write alphabetical order. One we got substitute methyl. One we got substitute nitro. One we got substitute oxo. So MNO. So first I should write the methyl. So methyl group is here. Okay. So where it is fourth carbon. So first what I will write 4 methyl. 4 methyl. Then I have completed writing the methyl. Then N nitro 6 nitro. 6 nitro over, then 3 oxo. So all substitute I am able to mention. After that, you should worry about the word root. Okay. 7 carbons are there, hept. And there is a double bond 4 ene. Okay. And then aldehyde. So aldehyde will be always in the first carbon. So you need not to mention the one. Okay. So this is what naming is.